So today we're going to be doing the very last lesson of linear inequalities, and it's all about solving multi-step inequalities. So up to now you guys have seen these types of linear equations, but now we're going to throw the inequality symbol in, which makes it an inequality, evidently, and then that's going to be our biggest difference between the two. Again, just a reminder, an equation has one solution. An inequality has a whole bunch of possible solutions, okay? So we're just going to go through about 3 or 4 examples, and then that will be it. So if we look at our very first inequality here, we want to show it algebraically and graphically, and that's when we find our solution. Don't worry about verifying it, because what we'll do is we'll verify on another example. So we start with x divided by 4 plus 3 is greater than 8. Now, a quick little reminder to yourselves that if you are dividing or multiplying by a negative number, you must switch the symbol in regards to which way it is facing. So we want to start with isolating a variable. So isolate your variable. And as you're doing that, you always want to think BEDMAS backwards. So SAMDEB, okay? So first things first, you look on the side with your variable and you say, okay, what do I have here? I have a division and I have an addition. What comes first? Subtraction, addition. So we must subtract 3 from each side in order to keep our inequalities balanced, but also to isolate our variable. So here we have x divided by 4 is greater than, and 8 minus 3 is 5. Now, the very next part to this, we have x divided by 4. And this, ladies and gentlemen, right here is a one-step linear inequality. So this is the kind of thing that we've already seen in the previous lesson. But just to go over it again, x divided by 4, what's the opposite operation of a division? Well, it's a multiplication. Now, reminder, we're not multiplying by a negative number, therefore our inequality symbol will remain the same. So then we do x times 4, and that will give this a value of 1. And what we do to the one side of the inequality, we must do to the other side. So we times the 5 by 4 as well. Therefore, x is greater than 20. Now, this right here is algebraically. So that is one final answer that we do need to square off. Now, how do we show this graphically? Well, we want to use a number line for this. So we start by putting our number line down. Put your 20, which is your boundary point. Put that 20 in the middle and add numbers, a few on the right side, a few on the left side. Now, reminder, going back to the last lesson, we have to look at what type of an inequality symbol we have in order to determine if our circle is going to be filled in or not filled in. Because it does not have an equal sign under it, this means that 20 is not a possible solution, which means that it is not a part, our boundary point is not a part of our solution. Therefore, we need to have an empty circle just above it. And then, because x is greater than 20, we have to put an arrow facing the numbers above 20, or higher than 20, sorry. And that's that. That would be our second answer, graphically. So you can square that off as well. Now, moving on to example B, a little bit more steps to deal with here. It's the same type of idea as when we had to deal with the equalities when we had both of like terms on both sides, okay? So we have a 5 and its like term is 29. And the reason that the two of them go together is because they're both considered constant terms. And then in this case here, you have negative 2x and you have 10x. Those are like terms as well because they both have an x in them and the exponent is 1. So you must get your, you must put your like terms together on the same side. It does not matter which side they go on as long as you have the x's on one side and the constant terms on the other. So for me personally, what I'm going to do here is I'm simply going to do minus 5 on this side to get rid of it, and I'm going to put it with my constant term here. So I have negative 2x is greater than 10x plus 24. And again, I did not change my inequality symbol. It stays the same. Now, if I have positive 10x here, I want to subtract 10x because I'm not trying to separate the 10 and the x yet. That comes afterwards when I only have one term with x's. So this will get rid of that. And what I do to one side, I must do to the other. So therefore, it's negative 12x is greater than 24. That's our solution at the moment. That's our inequality at the moment. Now, to get our inequality, to get our solution, our final solution, what we have to do is we have to do negative 12x. It's multiplied, so we need to divide. And look at this, ladies and gentlemen. We are dividing by a negative number, which means our inequality symbol, ding, 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 something has to happen to him. So we're going to do that in just a second. Just like that. Now, my x, and then 24 divided by negative 12 is negative 2. And I said something has to happen to this inequality symbol here because we divided by a negative number. It needs to face the other way now. Therefore, in order for our original inequality to be satisfied, to be true, in other words, you have to have x as a value that is less than negative 2, and it cannot be equal to negative 2. So how do we verify that as a solution? First off, we square off our solution. Second of all, here's how we verify. Take your original inequality. 5 minus 2x is greater than 10x plus 29. Now, according to this solution right here, any value of x in this inequality must be less than negative 2 if this solution is correct. So how do we verify? Pick a number that is less than negative 2. So for example, let's pick negative 3. So 5 minus 2, and instead of writing x, we're actually going to substitute it with the value negative 3 because that's the one we picked. If you pick negative 10, then you substitute with negative 10. It really doesn't matter. So negative 3 is greater than 10 times negative 3 plus 29. And now we go and we figure out what the value of this side is, what the value of that side is, and we determine if this in fact is the correct inequality. So 5 plus 6, because it's negative 2 times negative 3. So it becomes a plus 6, is greater than, this is negative 30 plus 29. Add them together on each side separately. It's 11 is greater than negative 1. And that, in fact, is true. Therefore, our verification is correct, and so our solution is correct as well. And that's how you verify. Moving along. So now this one here has greater than or equal to. And so we're going to verify this solution simply because I want to point something out to you guys that is very important when you verify a solution when it has the equal to symbol under it. So we have 4 times x minus 2 is greater than or equal to 5x minus 12. All right, let's get started. You would do your distributive property. So you would have 4x minus 8 is greater than or equal to 5x minus 12. Now we do the exact same thing we just did for the previous example. We put our like terms together. So let's say in this case here, I'm going to take my 4x and put it on the other side. I want to show you guys that you don't always need to have your x's on the left or on the right, but you can if you have a preference. So subtract 4x because we're just trying to move it to the other side. We're not trying to separate it yet. The separating comes after. So subtract 4x. So therefore I have negative 8x is greater than or equal to x minus 12. Now I add 12 on each side to get the like terms together on separate sides. So I have 4 is greater than or equal to x. And that is my solution. So that's fine, not a problem. Let's verify it. 4 times x minus 2 is greater than or equal to 5x minus 12. And this is my verification, okay? So now the problem here is if you would have accidentally made a mistake and you would have, let's say, for example, switched the opening of this symbol, and you would have thought, oh, well, x has to be greater than 4, and you fill it in here. But what you've done is you pick the boundary point 4 to fill this in. The problem with that is you're right. It is welcome to, x is welcome to be a value of 4 because of our symbol equal to at the bottom here. But the problem is if you use 4, no matter which way that this symbol is facing, it's always going to be right because of this equals to sign here at the very bottom. So I recommend that you never pick the boundary point that is shown in the solution here. I recommend that you pick a possible solution that is not the boundary point. And that's because, as I said, your 4 would be correct no matter what you had for an answer here, okay? So don't ever pick the boundary point, okay? So we have to pick a number that is greater than or equal to, that is less than or equal to 4. So let's pick 3. So 4 times 3 minus 2 is greater than or equal to 5 times 3 minus 12. All right, so that means it's 4 times 1 because we do 3 minus 2 because in here we use bed math. Greater than or equal to 15 minus 12 because that's 5 times 3. So 4 is greater than or equal to 3, and that is, in fact, correct. All right, so let's move along here. Ooh, word problems. I know how much you guys love these ones. All right, let's get started. First things first, in question A, you are going to name your variable, tell me what we are looking for, and in question A as well, we're going to model it using an inequality. Now, the thing is, sometimes you have to look at B to determine what exactly you're looking for, but in this case, everything should be fine, okay? So Danny started his own computer repair business. He offers his customers 2 payment options. Option A has a base fee of $40. So option A, base fee of $40. Now a base fee means that you pay it no matter what. It doesn't matter, okay? Plus $8 per hour. Now that per hour that you guys are seeing, that per, it automatically states it's a multiplication. So keep that in mind, okay? And then option B, no base fee. It just costs $15 per hour. Again, that per hour comes up. So how many hours? Right there, that automatically tells you X equals hours. Right there. So how many hours does a repair job have to take in order for option B to be less expensive? In this case here, less expensive is actually probably one of your most important things that you could be looking at. And here's the reason why. Less expensive tells you exactly which way you are going to, which inequality symbol you are going to use, because less expensive automatically indicates that one option is better than the other option. So let's build up option A first. Base fee of $40, $8 per hour. Well, we said X was hours, so it's 8X plus 40. Okay, and then option B on a little bit of space in between, no base fee, it's just $15 per hour, so 15X. Now, we want for option B to be less expensive. Less means it's not equal to. It means that it's cheaper. So therefore, option A would have to be greater than option B. So in this case here, we have no choice as to where our x's and our constant term go because we only have one constant term but two terms with x. So therefore, we must take this 8x and we must move it over to the right-hand side. So let's subtract 8x. Subtract 8x. So it's 40 is greater than 7x. Now, what we're going to do next is we are going to do a division of 7 on both sides because it's 7x. It's being multiplied, and that's what we want to get rid of. So, what do we do here? We have 40 divided by 7 gives us 5.7 is greater than x. So, we have to interpret that solution. You have to write a sentence for it. There's no question about it. So therefore, you would say for option B to be less expensive, it would take 5.7 hours. And that is your final answer. Now, the next question here, how many hours will option A be less expensive? Well, it's very simple. If after, go back. Look, option B for option B to be less expensive, it would take 5.7 hours. That's wrong. That's very, very wrong. I have to put words like a minimum of, a maximum of, less than, more than, things like that. Miss W, what are you doing? So look here, it would take more than 5.7 hours. And we say more than because of the fact that it cannot be equal to 5.7 hours according to our inequality here. So it would take more than 5.7 hours for option B to be less expensive, okay? So now let's go and take that and let's reverse how we would say these kinds of things, because now I want to know after how many hours will option A be less expensive? Well, that would just simply mean that we would have taken this inequality and we would have switched it around. But that doesn't mean that our answer would have been different. It just means that our symbol, our inequality symbol, would have been the opposite, facing the opposite way. So if it's, oh my goodness, okay, let's retract this. Less than 5.7 hours. Oh my goodness, I'm so sorry, you guys. I apologize for all that last minute or two here. Okay, because it's 5.7 is greater than x. Now, if we switch that around, our answer here would be 5.7 is less than x, which means that for option A to be less expensive, it would take more than 5.7 hours. And we know this because, like I said, all we have to do is switch our inequality symbol in this top inequality here, and that's it, because now it's just simply asking us the opposite of question A. So, ladies and gentlemen, my sincerest apologies for the last few minutes there with my little mistakes, but hey, we're all human, it happens. If you guys have any questions, please let me know. You know how to get a hold of me. Otherwise, good luck, everybody. And just a quick little reminder, this is the very last lesson of our unit. So that means that there will be a unit review coming very shortly after this lesson. Please work on it. This is a major concept for next year for grade 10 especially. And also that means there will be a test coming up, but we'll discuss that at our next meeting. So have a great day, guys.